Today, I am going to continue the chemical calculations, the third part of the chemical calculations, right? Do you remember last day I told you about the redox equations, calculation related with the redox equations. Today, I hope to explain you chemical calculations which are related with the titrations. So titration is the most important part of the chemical calculations because you know that stoichiometry. Stoichiometry is the simplest molar ratio of the reactants of a chemical reaction. Smallest molar ratio between the reactants of a chemical reaction. During the balancing equations, we are giving these molar ratios, stoichiometry. Titration is the one method to determine the stoichiometry of a reaction, right? So it is important to know the titrations we are going to study in three parts. First, in chemical calculations, in detail, after that, in physical chemistry, after also, we will study again titrations. So it is very important part of the calculations. Then, the simplest form of the titration is the acid-base titrations. Acid-base titrations. Acid-base titrations. As an example, acid can be taken as HCl, hydrochloric. Base can be taken as sodium hydroxide, NaOH. So there we explained as strong acid, strong base. So this is strong acid, strong base titration. There are other type of titrations are also. Today I'll explain you strong acid, strong base titration. HCl is an strong acid, strong base. Why they are explained as the strong? That means if we take a bottle of HCl, it is the bottle of HCl. This bottle contains H plus and Cl minus ions only because HCl undergoes ionization giving H plus ions and Cl minus ions. The decomposition is ionization is full ionization, complete ionization, right? So in this bottle no HCl molecules, it has only H plus and Cl minus ions. That means HCl undergoes complete ionization to give H plus and Cl minus. If 1 mole is present, 1 mole of H plus, 1 mole of Cl minus are given. No molecules. So only contains ions. This is the strong acid. Similarly, strong base also same. If we take NaOH aqueous solution, it also undergoes complete ionization forming Na plus Cl minus. 1 mole of NaOH to give 1 mole of Na plus, 1 mole of OH minus. NaOH also undergoes complete ionization. If we take a bottle of NaOH, it has totally Na plus and OH minus ions only. So that means strong acid, complete ionized, strong base are also complete ionized. Then the first titration is strong acid, strong base titration. If we take 1 moles per cubic decimeter aqueous solution of HCl, it has H plus ions also 1 moles per cubic decimeter, Cl minus ions also 1 moles per cubic decimeter. This is the property of the strong acid. Strong base is also same, right? Then the first titration is strong acid, strong base titration, right? Then during the titration, we are taking a known concentration. If it is 1 m NaOH, known volume 25 cubic centimeter is taken normally, generally, to the titration flask. Then we know the number of mole. How many moles we have taken? Concentration 1, volume 25 divided by 1000. Then how many mole? 0.025 mole of NaOH has taken. Then this is the burette. The burette also having known concentration. If it is 1 m HCl solution, right? Now we are going to find out, to be neutralized, the total amount of NaOH here, how much of HCl should be required. Then we are adding dropwise HCl until the reaction will be gets completed. That final step we explained as endpoint. It is the point, is the really it is a HCl volume. Endpoint is 20, maybe 25. If we add 25 cubic centimeter of HCl into that solution, the total amount of NaOH gets completely reacted. So we are going to find out that volume, right? Then how we know that? When we are adding HCl dropwise, little by little undergo the reaction, then how we know that the reaction gets completed or not completed? HCl is colorless, NaOH also colorless. They react to give NaCl. It also colorless. Then how we know that whether reaction has completed or not completed? So to determine that final state, we have to take an indicator. It shows us the reaction gets completed. How it tells that? When we are adding some particular indicator to this solution, it gives some color. So you know that the typical indicators, methyl orange, one indicator, phenolphthalein, another indicator. If we add methyl orange few drops, that solution gives orange. So methyl orange indicator gives orange color in the basic medium. When you are adding HCl, little by little, basicity decreases due to the reaction. Finally, if the required amount totally is added into the solution, it has sodium chloride only, no acid or base. After that, if we add one drop of HCl, the whole medium becomes an acid. So methyl orange gives orange color in the basic medium. If it becomes acidic medium, it gives red color. Then we are observing during the addition of HCl when the orange color becomes red color. So when it becomes red, we stop the addition of HCl, read the added volume of HCl. It may be 25 cubic centimeters. Right? Then we can go to the calculation. NaOH, how many moles? 0.025. We have taken. How many moles of HCl was added? 1m 25 into divide by 1000. Here also 0.0025. Then NaOH we have taken 0.025 mole. HCl also requires 0.025 mole. Then they react 1:1 ratio. This is the stoichiometry of the reaction. The titration helps to determine the stoichiometry of the reaction. Then, after the determination of the stoichiometry, we must write the balance equation. NaOH 1 mole, HCl 1 mole. Then we are unable to change that number of moles here. It should be 1:1. Then we must write the equation without changing the number of moles of HCl and NaOH. To give that, Na should be reacted because it is plus with Cl minus NaCl. Then OH gives water. So NaCl 1 mole and water 1 mole should be formed because the stoichiometry is 1:1. We are unable to change that stoichiometry. It is a method of the determination of a stoichiometry using a titration. Right? Then, this is the normal titration, strong acid and strong base titration. Today, I am going to explain a typical titration. Most of the problems are related with this theory were given in our paper, MCQ paper, essay paper, in both papers, right? But to do such problems, you must know this theory. Sodium carbonate Na2CO3 plus HCl the titration between sodium carbonate and HCl. How they react? So what is the stoichiometry between sodium carbonate and HCl? Right? Then, to study this reaction, experimentally we are taking two titrations. Both are identical. One name Na2CO3 10 cubic centimeter. Two volumes are taken. One name sodium carbonate 10 cubic centimeter in each, in both. Here also we are taking to the burettes one name HCl. Both are identical two titrations. But the difference is, if this is A, this is B, indicator to the A add phenolphthalein, to the B methyl orange. This is the only difference. Only difference is indicators. If the phenolphthalein is added to the sodium carbonate, it is basic, so it gives pink color. Initially pink. Methyl orange gives, it is basic, orange color. Initially. Then we are adding HCl group wise. At the end point, that solution gives colorless, because it becomes anacidic. The required volume of HCl 10 cubic centimeters. 10 cubic centimeters, during the descent of 10, it becomes colorless. The reaction gets completed. But the titration B, to give the orange color to red color, it needs 20 cubic centimeter of HCl. 20 cubic centimeter of HCl. Right? See here, the same reaction, identical to titrations, same reactants, but phenolphthalein tells us reaction has completed. Methyl orange tells after the addition of 20 cubic centimeter, it has completed. So, it is clear that in these two titrations, two reactions are occurred. Right? Only difference is indicator. But you must know that indicator is unable to change the reaction, but it can change the step of the reaction. Then, if we consider A, we can calculate NHCl 1 into 10 divided by 1000 mole, 0.01 mole of HCl, sodium carbonate. 0.01 mole of sodium HCl also 0.01. Sodium carbonate also in Na2CO3, it also 10. 10 was taken. It also 0.01. The number of moles of HCl and the number of moles of sodium carbonate, they react each other, giving the complete reaction. But reaction occurs 1:1 ratio. 1:1 ratio. Then we can write the equation. How the reaction occurs 1:1 ratio. How the reaction occurs 1:1 ratio. Sodium carbonate plus HCl 1:1 ratio. We are unable to change the number of moles here and here. Then what are the compounds can be formed? Sodium chloride, Na plus Cl minus. NaCl, 1 mole can be formed because 1 Cl here, but here Na2, but we are unable to change this number of moles 1:1. Then NaCl formed. What are the remaining amounts? 1 sodium, here H, CO3 also. Na2CO, NaH, CO3, NaHCO3, sodium bicarbonate. Then during this reaction, they react 1:1 ratio to give sodium chloride 1 mole and sodium bicarbonate 1 mole. When this reaction gets completed, phenolphthalein changes the color. Phenolphthalein changes the color. So this is the reaction should be occurred. But the other reaction, NaCl, 1:20 divided by 1000, 0.02, because the titration P in the presence of methyl orange, the required volume of HCl is 20. So 0.02 mole of HCl required for the completion of reaction. Then NaOH, Na2CO3, 1:10 divided by 1000. The volume of sodium carbonate is 0.01 mole. So here 2 mole 0.201 Na2CO3 plus HCl, they react 1:2 ratio. 1:2 ratio, molar ratio. This is the stoichiometry. Then, if we consider these two reactions, first one, sodium carbonate react with HCl to give sodium chloride and sodium bicarbonate. The reaction occurs 1:1 ratio. In the second titration, Na2CO3 plus 2HCl, 1:2. Then it is clear that here Na2, 2Cl, 2NaCl can be formed. Then CO3 plus 2H gives CO2 plus water. This is the second reaction. Then during the titration we can observe that During the first iteration, no effervescence of carbon dioxide, not the evolution of gas unable to observe. But during the second reaction, second iteration, we can observe the evolution of carbon dioxide also. So it is clear that sodium carbonate gets completely reacted with, according to this equation, 1 mole of sodium carbonate is required, 2 moles of HCl to give sodium chloride and carbon dioxide and water. Then, what is the meaning of the first reaction? So it needs 1:1. If 1 mole is added, sodium chloride plus NaHCO3, sodium bicarbonate was formed. If we add more HCl without stopping the titration, that sodium bicarbonate again reacts with HCl was added to give sodium chloride plus water plus carbon dioxide. Water plus carbon dioxide. But reaction is not occurred because phenolphthalein gives the color change, so we stop the titration. Right? Then, if we add these both reactions, 1:1, first reaction, sodium bicarbonate was formed. If the sodium bicarbonate was reacted again with HCl, sodium chloride, water and carbon dioxide form. If both reactions are occurred, if we add these two reactions, right, sodium carbonate cancelling out, sodium carbonate 1 mole here, HCl 2 moles here, NaCl 2 NaCl, CO2 plus water should be formed. So it is clear that we must understand that sodium carbonate react with HCl by the two steps. Right? So these two steps we can be identified using the indicators. If we add without indicator until the CO2 is evolved, the complete reaction should be occurred. But to study the two steps, we can use the two indicators. Right? Then this is the final decision. So sodium carbonate reacts with HCl in two steps. First step, what will happen? Sodium carbonate react with HCl 1:1 ratio, giving sodium chloride and sodium bicarbonate. Half of the reaction gets occurred. At the second step, the so formed sodium bicarbonate again reacts with HCl to give sodium chloride plus carbon dioxide plus water. Then to obtain the final full reaction, we must add these two reactions. Generally, this is the final reaction. Sodium carbonate plus 2HCl, sodium chloride and carbon dioxide and water are given. Generally, if the reaction gets completed, this should be the final reaction. Right? Then this is very important for the calculations. You must know that Sodium carbonate reacts with HCl in two steps. First step, it undergoes reaction 1:1 ratio, giving sodium bicarbonate, not the evolution of carbon dioxide. If the reaction occurs 1:2 ratio, sodium chloride is the final product, giving out carbon dioxide and water. Right? Then there are different problems related with this theory. Then you must know that how the sodium bicarbonate react with HCl. Then you have a problem. Is it occurs due to the influence of the indicator? No. Later we will study indicators. Indicators are unable to change the reaction. They show the reaction for me. That's all. We will study in the equilibrium lesson later what are the actions of indicators also. Right? Then today, next day I will do some problem related with this theory were given for your exam. Then thanks very much for you. Then I will continue my chemical calculation lessons further and further. I'll give you different problems to illustrate the different theories, different fundamental theories. Right? Then I want to tell you one message. I am connected into the education department as a teacher at an institute. Then I am enrolling for the paper corrections also. Then I have the ability to give so many advices for you. How to write the correct answers. How do you manage the time. Right? Then all the things I can explain you. So I hope to start in future after the results were given out, right? Then we'll be out recently. After that I will start revisional courses with theory also. Revision. Then I will explain you how to write the answers, how to select the most appropriate answers for the problems, and how we manage the time, all that. Then I invite you to connect with me for my lessons in future. Then be with me during these lessons. I will be with you. Right? 2017 lessons also I will start recently. Then I will invite all of you, my dear children, to be participated with me. Thanks very much. See you later.